Okay, I'm recording. So if you notice I've got to record, please remind me immediately. Okay. So this was drafts when I was preparing for today's class. Okay. Let me first show you what I write on the drafts. This is just draft. Do not copy yet. I'll rewrite them on this black lecture notes. Basic definition. You have to know what is tangent, what is cotangent, what is second in terms of sine and cosine. Rewrite everything in terms of sine and cosine. That's so-called basic definition. Then we have the Pythagorean theorem. The Pythagorean theorem says that sine squared plus cosine squared equal to 1. So you can move either 1 to the right or left. If you move to the other side, then see what you get. Sine equal to 1 minus cosine, cosine equal to 1 minus sine squared. That's it. I'm just giving a brief review. I will rewrite them again on the new paper. Do not copy it. Do not copy it. Then the third component is the even and odd property. The sine function, the odd function, it means sine negative angle equal to negative sine the positive angle. Negative sine the positive angle. Cosine is an even function. It means whether the angle is positive or negative, you still get the same value, okay? So let me rewrite on the lecture notes today. Basic definition. We are rewriting everything in terms of sine, in terms of tangent and cotangent. Tangent theta is sine over cosine. Cotangent is sine over sine. Second is 1 over cosine. Cosecant is 1 over sine. Okay, that's it. Just rewrite everything in terms of sine and cosine so that we would be able to simplify our future formulas. Second, Pythagorean theorem. Pythagorean theorem, sine squared plus cosine squared equal to 1. Or sine squared equal to 1 minus cosine theta. This is from this. You just move 1 to the other side. So you just need to memorize this one. And you can create this one by moving cosine to the other side from this one. Similarly, this can also be created. Okay? Sine, cosine. And lastly, this even and odd property. So I'm running out of space here. So sine negative theta equal to negative sine theta. Cosine negative theta then equals to cosine theta itself. Okay, so before we get started with the question, anyone has any question about this property? Anyone has any question? Okay, I'll give you 1 minute to review it. If you don't remember them clearly, just give you 1 minute. Since we have plenty of time in today's class, all the questions can be done very quickly. Okay, once you know the properties. So I'll give you 1 minute to review it. Feel free to ask me any question. Okay, 1 minute.
For the cosine of the even and odd property, it's just normal. It just equals the regular cosine.
Yeah, cosine negative theta equal to cosine theta. So,
Thank
so let me elaborate a little bit. Why the even and odd property work? You guys know the sine is a y coordinate, cosine is an x coordinate on the unit circle, right? So if we move this angle, let's say you have an angle here, move to the other side, make it a negative angle, does the y coordinate changes value? Yes. The y coordinate flip to the negative value, okay? However, does the x coordinate change its value? No, they still use the same x coordinate. So the negative angle still has the same x coordinate, just like this. Okay, that's why it is true. Okay, thank you for asking. 1 minute to think about it. Feel free to ask me any question. Make sure you get all of them, all of them. Once you get all of them, every other question can be done very quickly. Okay, I think we're ready to continue. Anyone has any more question? Okay, let's continue. So let's look at the first one. First one is always the easiest one. Rewrite everything in terms of sine and cosine. Okay, this. To do this question, you just need the basic definition. What is cotangent in terms of cosine and sine? What is cosecant in terms of sine? Okay, they're all here. So we can just write cotangent theta secant theta equal to cosine theta sine theta. What is cosecant? 1 over sine theta. Make this horizontal line longer so that you know this is a fraction, this is another fraction. Then you multiply both sides with sine, cancel this sine in the bottom, cancel this sine in the bottom. You get cosine theta. That's it. Anyone has any question? Any question? Okay. Look, it's just so easy. This looks complex. However, we still have ways to do that. In order to solve this problem, we have to use a Pythagorean theorem. Pythagorean theorem. I will show you how we use the Pythagorean theorem in this context. Okay, so cosine theta, we want to show this equality holds. Sine theta. What do? We see 1 plus sine theta. And we don't know what it is. And we also see cosine theta. So in order to show this equal to this, how about we show when they minus each other, you get a 0. Okay? How about we show this minus gives us a 0? So let's just show it right now. We calculate there are two fractions with different denominators. So we make them share the same denominator by multiplying each other what kind of component they do not have. For this guy, it needs a cosine theta. So we multiply 1 is cosine over cosine. For this guy, it needs a 1 plus sign. Add a process so that it distinguish with each other. Okay, after you do such a multiplication, they are sharing the same denominator. This cosine times cosine, which is cosine squared. This is 1 minus 1 plus. Remember the very famous formula. Anything 1 minus 1 plus give you square minus. Okay? Anyway, need me to elaborate on this formula? Okay, so you can apply this formula to here. 1 minus 1 plus gives you 1 squared minus sine squared. And don't forget that you have minus sign here. So my write the minus sign. Keep everything here in terms of process. So 1 minus sine squared theta. Okay, anyone has any question how we get here? Okay, so let's just continue. 1 minus sine squared theta. What is 1 minus sine squared theta? 1 minus sine squared theta is just...
Is cosine squared of theta.
Very good, very good. You get it. Look, what do we have here? 1 minus cosine squared. Cosine squared just here. 1 minus sine cosine squared. Derived from Pythagorean theorem. That's why I give you 1 or 2 minutes at the beginning of class to look at them and think about them. Okay. So this is cosine squared. Cosine squared minus cosine squared. You get a 0. Now you see the same thing minus itself. So 0 over 1 plus sine times cosine give you eventually 0. Okay? So that's why we claim they are equal. Because when they do the subtraction with each other, we get a 0. So they are equal. Anyone has any question? Does it something easy or hard for you guys? The procedures.
Are we gonna do more problems using the Pythagorean theorem?
Yes. Yeah.
Okay.
Could
Yes.
you explain how the denominator is equal to 0?
Denominator never equal to 0. This is a nominator.
Oh, okay. That makes sense. Sorry.
Okay, cool. Okay, so again, let me re-emphasize that. All we need is those basic. We learned in the previous sections. Then we can do some simplification work from using them. Okay, and everything would be easy once you get this part. Okay.
Sorry, can you keep it on the screen? I'm still trying to write it down.
Okay, no worry.
Thank you.
I always make a photocopy of it and upload it in a Canvas after class. So in case you miscopy something, there will be always a copy for you in the Canvas under the same module of this week. This question looks hard. Cotangent, cosine, but my students, never worry about if you see something complex. If you see something complex, always convert something into easy, which is sine and cosine. So let's convert this into sine and cosine. Let me just copy the question. Okay. Once you write a cotangent in terms of sine and cosine, what do you get? You get this. What can you do from here? You see cosine, cosine, cosine. It seems that we can factor out this cosine and cancel with the cosine in the bottom. So let's factor it out and cancel in the bottom. You see this? I factor out the cosine in the numerator. Okay, so now we can cancel the cosine here. See what you get. This is what you get. However, look at this fraction. This is one fraction. What if we split it into two fractions? We get 1 over sine, sine over sine. Sine over sine is just 1, right? So you get 1 over sine plus 1 plus 1 over sine minus 1. Okay, I just split this fraction into 2. So what do you get here? You get 2 over sine. 1 minus 1 is 0. That's it. You reach the end of the class. Or reach the end of this question. Sorry, not the end of the class. Any question?
Would you be able to go over that last part again, Professor, one more time?
This one?
Yes, because I got to the point where it's the 1 plus sine of u over sine of u. How did you split that up again?
So look at this fraction. This is 1 over sine plus sine over sine, right?
Yes.
Sine over sine is just 1. 1 over
Okay.
sine is still here. Okay, thank you for asking. Okay, anyone has any question before we continue? Okay, the sum is all good, so let's continue. Again, looks very complex. A bunch of stuff. However, remember our number 1 principle. Convert everything in terms of sine and cosine. Okay, so let's do it. So what does this equal to? I just write this equal to, this is in terms of sine already. So we don't need to handle this one. The bottom have a tangent, so write sine v over cosine v times sine v minus sine v over cosine v. Okay, I just converted the tangent in terms of sine v and cosine v. That's it. Does anyone has any question on this one? So let's continue. What does this guy equal to? Huh. No idea. Looks so complex. We see two fractions. How about we merge the two fractions together? Sine squared v minus 1 equal to, merge them together, what do you get? You get 1 over cosine. I factor out the cosine because each of them has cosine. Sine squared minus sine. That's it. What can we do from here? Well, there are many ways you can go from here. Let me tell you what I would do. I see something similar in the Pythagorean theorem. In the Pythagorean theorem, we have 1 minus sine squared equal to cosine squared. Here is sine squared minus 1. So you have what you get just for this part.
You would get cosine squared.
Cosine squared is 1 minus sine squared. So look at this formula. Look at this one. Our question has sine squared minus 1. So just flip it. Flip the sign. So you have negative cosine squared. Right? Okay. So if you are not clear with this point, just think more about the Pythagorean theorem. How can you get one from to the other one? Or in other words, there's another way you can think about it. Sine squared is 1 minus cosine squared. Okay? So if you see sine squared here, so this is 1 minus cosine squared. 1 minus cosine squared minus 1. Let me write down. 1 minus cosine squared minus 1. 1 minus minus 1. So you get a negative cosine squared. Okay. Again, copy what is in the bottom. You have negative cosine squared here. Oh, by the way, I think I made a mistake. This is all right. This is all right. But this is not the shortest path to go to the solution. I apologize. This is not the shortest way to go to the solution. This is all right. I think I made a mistake. I think the shortest way is factor this. Okay, I apologize. Factor this. Because this falls into the a squared minus b squared pattern. What if you get a squared minus b squared? Which give you a minus b, a plus b. So what is this equal to? Sine v minus 1, sine v plus 1. So then for the numerator. What do you get for the denominator? Look at the sine squared minus sine. So you can still factor the sine out. If you factor the sine out, you got sine v over cosine v. Cosine is still here. Sine v minus 1. Okay. Sine v minus 1. Sine v minus 1. Then you can cancel this out. And this is this is a fraction. So when you are dividing a fraction, so multiply its opposite. So you get sine v plus 1 sine v times cosine v. Again, we can apply the technique to deconstruct this fraction. Sine v over sine v is just 1. Then 1 over sine v is 1 over sine v. Then you can multiply the cosine v in terms inside. So cosine v times 1 is cosine v. Cosine v times this guy is cosine over sine, which is give you cotangent v. That's it. Any question?
So the sine v just factors out since we have it in the top and bottom?
So were you asking me about this step?
Yeah.
Yeah, I just split the fraction into 2 1. Sine v over sine v give you 1. 1 over sine v is still here.
Oh, okay.
Okay. Anyone has any question before we continue?
Where did the cotangent come from again?
Okay, great question. So look at it, we have 1 over sine v here, and cosine v times 1 over sine v is cosine v over sine v. Cosine v over sine v is the definition of cotangent.
Okay, thank you.
Thank you for asking. Anyone has any more questions? Okay, let's continue. All the rest of today's class is going to be super easy. Just fall into the same pattern. Convert everything in terms of sine and cosine, then you're done with the question. Cosecant theta times cosine theta. We want to show that this is true. So let's if you write cosecant theta in terms of its definition is 1 over sine. And this is cosine. So this is 1 over sine times cosine, which give you cosine theta over sine. That is the definition of cotangent theta. That's it. Anyone has any question on this one? Okay, let's continue. This one also looks complex. However, convert everything in terms of sine and cosine. Sine, tangent, cotangent, blah, blah, blah. They all looks very... So let's do it. Tangent u, what is tangent u? Is sine u over cosine u. What's cotangent u? It's cosine over sine. Okay, minus cosine squared u. Sine over cosine, cosine over sine. So they cancel with each other. Eventually you get a 1 here. So you have 1 minus cosine u. So what is 1 minus cosine u? Again, Pythagorean theorem. The very famous ancient legend epic Pythagorean theorem taught us 1 minus cosine, just sine squared. Okay, so those two are derived from this one. So all you need to know is this one. Once you have this one, you can convert each of them. One minus cosine is just sine. That's it. You reach the end of the class, end of this question. Anyone has any question? Okay, if nobody has any question, let's just continue. That's our last two questions of today's class. Okay, well, once we are done with them, we are done with today's class. At the end of class, we have a quiz. Wow, this one looks very complex. So we want to show this is true. How do you show that? Again, we see two fractions. When you see two fractions, you can try to combine them. When you see one fraction, you can try to split them. So let's combine the two fractions and multiply whatever they do not have in the denominator. So multiply, this guy does not have 1 minus sign. This guy does not have cosine. So you see right now they are using the same denominator. Okay, once they have the same denominator, then we can proceed. To combine them. This times this guy is just itself. So you have 1 minus sine v squared plus cosine squared. V, okay? So once you get to this, what is this guy? This guy squared is 1 plus u sine squared v minus 2 sine v plus cosine squared v equal to 1 minus sine v times cosine v. That's it. I just completed a square here. You see, that's why we got a bunch of stuff here. Okay, anyone has any question on this one? Very happy we see that something squared plus something squared, cosine squared plus sine squared. So they add up to 1. 1 plus, this is 1, so minus 2 sine. So you get v2 minus 2 sine v. 1 minus sine v times cosine v. What do you see here? 2 minus 2 sine v. So you can factor 2 out. So this becomes 2 times 1 minus sine v, 1 minus sine v. Now what do you see? You can cancel this out, which will give you 2 over cosine v. Okay? So 2 over cosine v, what is that? 2 times cosine v, right? So what is cosine v? By the definition, it's just secant v. So 2 times secant v. That's it. Anyone has any question?
Where did that initial cosine squared v come from? The
cosine
very first,
here?
very first one. Just directly above
This
that.
one?
Yeah.
Very good question. So we want to combine the two fractions, okay? So we look at their denominators, try to multiply whatever they do not have, but the other part have. This guy do not have 1 minus sine v. So that's why we multiply 1 minus sine v, 1 plus 1 minus sine v, right?
Okay.
This guy do not, yes. Yes.
Gotcha.
So this guy do not have cosine. So we multiply cosine over cosine. So now cosine squared times this bottom is 1 minus sine v times cosine.
Okay, I see it now. Thank you.
Thank you for asking. Any question? Okay, it seems that we're really going to finish today's class early. Don't forget that we have a quiz at 9. And let's do the last question. This one, wow, looks like our final boss to beat in today's video game. How can we do this? Again, it looks very, very complex. However, whenever you see complex stuff, convert them into simple stuff, okay? That's a general philosophy of life or anything. Whenever you see complex stuff, convert them into simple stuff. So what can we do with this guy? We see second, we can convert second in terms of cosine, right? So this guy equal to 1 over cosine theta. How about second? This is 1 over cosine theta. Then what else can we do? We want to show they are equal. So we want to show this guy minus this left side minus the right side equal to 0. So what is this guy? This guy is sine 4 cosine 4 plus sine squared cosine squared. Okay, I forgot. I'm sorry, I should not write the equal sign here. We want to show they are equal. So that's why we want to show they minus each other give you 0. So what can we do from here? Looks all complex. I tell you, we see a bunch of fractions, and this all have cosine in the bottom. How about we just combine all of them in terms of cosine? Notice that everyone needs to be cosine to the 4th so that they share the same denominator, okay? This guy is already in the cosine 4th. 1 is still here. This guy cosine squared, so you need to multiply cosine squared to the numerator and denominator. So that's why you add cosine squared here so that it also shares this denominator cosine 4th minus this guy is already in the has cosine 4th in the bottom. How about this guy? This guy cosine squared. So you need to multiply cosine squared to the bottom and the upper part. That's what you have. Again, this still looks complex. So we try to combine all the terms we have. Okay. So 1 is still there. Cosine squared. Just write everything outside the processes. Sine 4 theta minus the plus sign. Once you get rid of the processes, becomes minus Okay. Too complex. What can we do? We have so much stuff here. Okay, so again, you may not know what to do. But don't worry. What do you see here? 1 minus cosine. Wow, 1 minus cosine.
Sine squared.
Is that a Pythagorean theorem? Great, that's Pythagorean theorem. Let's do the Pythagorean theorem here. So this guy becomes sine squared theta. So you have sine squared theta minus sine to the 4th theta minus sine squared times cosine squared over cosine 4th theta. Well, once you get here, it seems that we all stuck. However, don't worry. Sine and sine, sine, sine. We have so many sine. How about we factor out the sine squared? Factor out all the sine squared you have. You have 1 minus sine squared minus cosine squared over cosine to the 4th theta. Well, again, Pythagorean theorem tells us something. Look, 1 minus sine theta. What is 1 minus sine theta? What is 1 minus sine theta? Any brave?
Cosine squared.
Yeah, cosine squared. So this part is cosine squared. Then we minus cosine squared again. So what do we get for this part? 0, right? This is cosine. Cosine minus cosine give you 0. So 0 times this guy. So eventually give you 0 over cosine 4th. Give you 0. This is your final answer. Okay, anyone has any question how we get here?
Sorry, I missed it. How does the stuff inside the parentheses equal 0 again?
Very good question. So 1 minus sine squared is cosine, right? Do you agree with this?
Yeah. Okay, okay,
So,
okay.
okay, now you see cosine minus cosine. So give
Yeah,
you-
thank you.
That's it for today's class. Anyone has any question? Okay, so we still have 15 minutes before the quiz. Let me upload the quiz. And you can use this 15 minutes to do some quick review. And I send you guys an email talking about what is covered on this quiz. As always, the books, examples, and class examples. Okay, so let me upload the quiz. You can take this time to do some review.